Today we will be discussing SI units, standard units of measurement that we use in chemistry. We'll be talking about prefixes that you use associated with these units. And finally, we'll go over just several examples of converting from one prefix to another. On the screen right now, you have the first four SI units that we will use in chemistry. Please pause the lecture at this point so that you may have time to copy these down. First SI unit is volume. Volume is measured in liters and abbreviated with a capital L. We measure mass in grams with a lowercase g. We measure time in seconds with a lowercase s. And we measure length with meters, which is a lowercase m. Those four you're very familiar with. You use those in several science classes up to this point. Now, if we move to the second slide of our lecture, we have the next three SI units, one of which you might not have had as much experience with in your previous science classes as the others. Please pause the lecture at this point so that you have time to copy these SI units down. So the first SI unit that's listed on the screen here is a pressure unit that is measured in units of pascals, PA, millimeters of mercury, which is abbreviated mm for millimeters, and mercury symbol, Hg. Then you have units of torr, which is the same as its abbreviation. And finally, you have atmospheres, which are abbreviated ATM. For those of you that aren't familiar with the concept of pressure, pressure is defined as a force exerted over a given area. An example of this would be when you inflate your bicycle tire or your car tire. You are adding air. Air exerts a force over a given area on the inside of the rubber tire there. The next SI unit that we have listed here is temperature. Temperature is measured in degrees Celsius. Notice the degree symbol next to the capital C for its abbreviation, or measured in Kelvin units. Kelvin does not have a degree symbol next to it. It is just simply the capital K. Degrees Celsius is a scale derived from the boiling point and the freezing point of water as its reference points, whereas the Kelvin scale is an absolute scale where 0 on the Kelvin scale is absolute 0, point at which there is no molecular motion. The last unit that you have here is energy. The last measurement that you have is energy. Energy is measured in joules, and we abbreviate joules with a capital J. Down at the bottom of this screen, you have conversion factors. These are units of pressure. We have conversion factors to be able to go from one unit of pressure to another. 1 atmosphere is the equivalent of 760 millimeters of mercury, which is the equivalent of 101,325 pascals. The next slide that we have is your prefixes. So you use a prefix to show the size or the scale of the unit itself. We have several different prefixes that we use in chemistry, from very small, the nano prefix, up to very large, the mega prefix. I'll put those up on the slide here and then ask you pause the lecture so that you have time to write down these prefixes in your notebook. So the slide here refers to very small prefixes, prefixes that are designed to measure very small amounts, such as nano. We most often will use nano in terms of distance. When we talk about measuring wavelengths, a common unit of measure we use for wavelengths is nanometers. Nano is abbreviated with the lowercase n. The magnitude column represents the number of the base unit that would be the equivalent for that prefix. So if we use the example I just gave, nanometers, 1 nanometer is 10 to the minus 9th meters. So again, the prefix, and then without the prefix, the base unit by itself. The next unit listed here is micro. The micro symbol is a lowercase u, and the u has kind of a little tail on the front of it. And that represents 1 micrometer would represent 10 to the minus 6th meters. The other small prefixes, milli, centi, and deci, you're all very familiar with. Then you have your base unit in the middle of the chart, and then below the base unit you have all of your prefixes that are larger than 1. The most common one of these four we use in chemistry is kilo, either referring to mass, kilograms, or distance, kilometers. Kilometers is represented with a lowercase k and has a magnitude of 10 to the third. For example, 1 kilometer would be 10 to the third meters. Now, you're going to have a quiz on these SI units and these prefixes in a later class. Please make sure to review the material that's been presented in this video, and also make sure that you are comfortable converting from one prefix to another. We'll finish today by showing you two examples of those conversions. First, let's say we had a large unit, 1.3 kilometers, and we wanted to go ahead and convert that into just simply its base unit, meters. We would set up a one-step monorail, and we go back to the previous slide. We recognize that the magnitude that was given was 10 to the third, so that's always associated with your base unit. So we'd have 10 to the third meters, and that equals 1 kilometer. We set up our dimensional analysis so that kilometers cancel out with kilometers. We multiply the two numbers on top by one another, and we get 1.3 times 10 to the third meters. If you're not familiar with or comfortable with scientific notation at this point, you can also write this number out. This number written out would be 1,300 meters. Either answer would be acceptable at this point in our curriculum. One more example of this, let's say we were going from a small unit to a larger unit. Let's say we had 8.2 milligrams. We wanted to go ahead and convert that into our base unit of grams. The milli magnitude was 10 to the minus third, so that would be 10 to the minus third grams for 1 milligram. We would cancel out milligrams, and then multiply the two values together, and we get 8.2 times 10 to the minus third grams there. Please make sure to do the practice problems that have been assigned by your teacher. Come in and get help from your teacher during the ICE period with these conversions if you struggle converting one unit to another in preparation for our quiz coming up.